Well, hello guys, Mr. G here, and we're going to be making a video for the grade 8s and 10s. However, this one is also applicable for all the grades. We're going to be speaking about the kinetic molecular theory of matter, but very quickly we're just going to do an experiment to prove something. When we did kinetic molecular theory, we learned two very important points. First of all, you learn that everything is made of very small particles and you cannot see those particles, and they tell you something else. They told you that there is spaces between the particles and that they are moving. So there was more things, but this is mostly what they told you. Kinetic molecular theory, everything is made of very small particles, there are spaces and they are moving, those particles. And then you picture something like this when you have, for instance, a beaker with water inside, and then they say between the water particles there is empty spaces, as you can see here, and those particles of water are moving. But it's very difficult to actually believe that because you cannot see it. However, what if I tell you there is an experiment, very simple, to see that there is in actual fact a space between the particles as well as the particles are moving. In this simple experiment, we are going to have a beaker with water, just water in the beaker. Now it's very difficult to imagine that there is a space between the water when you see it just like that. So what we are going to do is we are going to add few drops of ink to the water. And then you can see that the ink is going to go all the way to the bottom of the water and eventually is going to mix with the water. This one is only possible if there is a space in between the particles of water. If there is not a space in between the particle of water, the ink cannot mix. There is no space to move past the particles of ink. So ink is made of particles, water is made of particles, and because there is a space between the particles of water as well as the ink, then the ink can move from one side to another. There is a process called diffusion, and is when these particles of ink, for instance, are mixing with the other particles of water. Now they're moving from one side to another, and that is a proof that the particles are also moving. Not just there is a space, but the particles are moving, guys. And here you can see it with the fusion of liquid. Now, if nobody disturbs this system of water and ink, then what is going to happen is that eventually all the ink will be well mixed with the water. And if you can see, we fast forward this one, then you can see how they are mixing all the way up until eventually you get all the ink mixed with the water, as you can see it here. So next time we're going to be seeing this one in gases, and then we are also going to see how temperature can affect the fusion of substances like this one here, how can affect the fusion of different substances. We are going to do those experiments in another time, but we go back here. What is going to happen is that if you add the ink, for instance, here in the water, and because there's a space and the particles are moving, eventually those particles of ink will start mixing with the water, as you can see there, and eventually they will be well distributed all in the water with the same concentration of ink. And this, guys, is called diffusion, and this is a proof that there are spaces between the particles as well as the particles are moving all the time. If neither of those were possible, then the ink will not be able to mix with the water. Guys, thank you for watching. This is Mr. G. Subscribe for the channel. I'll see you next time with another experiment about diffusion, in this case about gases.